Pythagorean Theorem, why it works. What is it? The Pythagorean Theorem is a squared plus b squared is equal to c squared, and that means the sum of the square of the two smaller sides is equal to the square of the longest side. Why? Helps establish relationships between the three sides of a right triangle. Interesting fact, the pygmy marmoset is the smallest type of monkey, with adults weighing between 120 and 140 grams. Now, let's see why it works. We have one triangle with side lengths of 3, 4, and 5. Now 5 is the longest side, or our C, and our two smaller sides, 3 and 4, are our A and B. So we have 3 squared plus 4 squared is equal to 5 squared. What is the area of a square? It is the square of one side length, or one side length times itself. In essence, the Pythagorean theorem is the sum of the area of two smaller squares, and that is equal to the area of a bigger square. So let's make a square with our longest side, 5. Let's start with adding one length of 5. Now we have two sides of our square. Let's add another. Now we have 3 sides of our square. Let's add one more. Now we have 4 sides of our square. We have also formed a bigger square with a side length of 7 because 4 plus 3 or 3 plus 4 is 7. Now we're going to find the area of the bigger square by finding the area of each shape inside. Let's start with finding the area of one triangle, and the formula to find the area of a triangle is 1/2 times base times height. And our base is 3 and our height is 4. Let's go ahead and substitute those in, and now we have area is equal to 1/2 times 3 times 4. Let's simplify the 3 times the 4, and the result of that is 12. And now we have area is equal to 1/2 times 12, and the result of that is 6. So the area of one triangle is 6 units squared. Now we need to find the area of all 4 triangles. In order to do that, we can multiply 4 times 6, and the result of that is 24. So the area of all 4 triangles is 24 units squared. Now let's find the area of the square inside by using the square formula, which is area is equal to base times our height. In this case, our base is 5 and our height is as well. So let's go ahead and substitute that in. Now we have area is equal to 5 times 5, and 5 times 5 is 25. So the area of our square inside the square is 25 units squared. Now we need to find the total area of the bigger square. In order to do that, we're going to add all the parts, the 4 triangles and the 1 square. Now we have 24 plus 25, and the result of that is 49 units squared, and that is the area of the bigger square. Now we're going to find the area of the big square using the outside numbers. The area formula for a square is base times height, and our base is 3 plus 4, and our height is 4 plus 3. Let's go ahead and substitute those numbers in, and now we have area is equal to 3 plus 4 in parentheses, which is our base, times 4 plus 3 in parentheses, which is our height. Let's go ahead and add the numbers in the first parentheses, and 3 plus 4 is 7, and now we have area is equal to 7 times 4 plus 3 in parentheses. Let's add the numbers in the parentheses, and 4 plus 3 is 7. Now we have area is equal to 7 times 7, and the result of that is 49. And the area of the big square, using the numbers on the outside, is 49 units squared. Now let's do a recap of what we've done so far. We found the total area of all the parts inside the bigger square, and that is 49 units squared. And we found the area of the bigger square with the outside numbers, and that is also 49 units squared. So we found the area of the bigger square 2 different ways using a visual representation on why the Pythagorean theorem works. Remember, in essence, the Pythagorean theorem is the sum of the area of the 2 smaller squares, and that is equal to the area of a bigger square. Now we're going to show you why this is the case mathematically. If we take a look at the left side of the screen, we have a square that is divided into rectangles and squares, and the area of this square is a plus b in parentheses squared, and that is because we are using the outside numbers, or in this case letters, to find the area, and both the base and the height are a plus b. If we take a look at the right side of the screen, we have a square that is divided into triangles and one square, and the area of this square is 4 times AB divided by 2 plus C squared, and that is because we are using the inside shapes to find the area, and we have 4 triangles and 1 square. Now we're going to simplify the equation a plus b in parentheses squared is equal to 4 times ab divided by 2 plus c squared. We're going to rewrite the a plus b in parentheses squared as a plus b in parentheses times a plus b in parentheses. Remember, the first a plus b is our base, and the second a plus b is our height, and the right side stayed the same. Now we're going to use the distributive property on the left hand side, and now we have a squared plus 2ab plus b squared, and the right side stayed the same. Now we're going to focus on the right hand side, 4 times ab divided by 2 plus c squared, and multiply 4 times ab divided by 2, and the result of that is 2ab. And now we have a squared plus 2ab plus b squared is equal to 2ab plus c squared. We have 2ab on both sides of the equation sign, so we can go ahead and cancel them, and now we're left with a squared plus b squared is equal to c squared, and that is why the Pythagorean theorem works mathematically. Now let's show you why this is the case visually by using a squared plus 2ab plus b squared is equal to 4 times ab divided by 2 plus c squared. Let's show the area of each shape on the left hand side, first by finding the area of the orange's square, and that is a squared. Let's find the area of one rectangle, and that is AB, and the other one is also AB. Now let's find the area of the grayish square, and that is B squared. Now let's show the area of each shape on the right hand side. Let's find the area of one triangle first, and that area is AB divided by 2. And let's add another triangle, and the area is also AB divided by 2. Now we have a rectangle, and the area is AB, since AB divided by 2 plus AB divided by 2 is AB. Now let's add a third triangle, and the area is also AB divided by 2. Let's add a fourth triangle, and the area is also AB divided by 2. Now we have another rectangle, and the area is also AB, since AB divided by 2 plus AB divided by 2 is AB. Now let's add the last shape, which is a square, and the area of the square is c squared. Now, since we have two rectangles, each with an area of AB on the left hand side and on the right hand side, we can eliminate them, and we're left with a squared plus b squared is equal to c squared. Remember, there's always tomorrow. Stay positive.